Welcome back to the deep dive. Today we're pulling out a stack of papers and diving into something that's become incredibly common, sparking huge debate. Electronic cigarettes or vaping. You see them everywhere, right? But what does the actual science in this recent research tell us?
That's precisely our mission today. We have a collection of recent research reviews and studies, and we're going to be your guides.
Okay.
Our goal is to unpack what the science is truly uncovering about vaping, what's in these things, how they might affect your health and the public's health, and cutting straight to it, whether they really offer a safer path away from traditional cigarettes. Think of us as translating some pretty technical findings into language we can all understand.
Absolutely. Consider this your shortcut to understanding the science on vaping. It feels like vaping just exploded onto the scene, didn't it?
It really did.
Evolving from looking like cigarettes to these sleek, powerful devices with a million flavors. But as these studies show, the story of their health impact is still, it's still unfolding.
Yeah.
So let's see what the research is revealing. All right, let's start simple. What exactly are these e-cigarettes, and what are you inhaling when you take a puff?
Good place to begin. The devices have changed quite a bit. The research talks about the early ones, the ciga-likes, which were pretty basic.
Right, I remember that.
Then came the mods, which are more complex and customizable. And now we have these popular pod devices like JUL. The designs have really evolved, often specifically to deliver nicotine more effectively.
That makes sense. Some of the newer ones seem to pack a much stronger punch.
Yeah.
And the liquid inside, the e-liquid, what's the base?
So the main components are usually liquids called humectants, propylene glycol, PG, and vegetable glycerin, VG.
Okay.
Now, it's interesting because the research notes these are generally recognized as safe or...
Great, yes.
But here's the crucial point the papers highlight, that GRAS status is typically for eating something or putting it on your skin. It absolutely does not mean they are safe to inhale, especially once they've been heated up.
That's a really important distinction.
Yeah.
Just because something is okay in your food doesn't mean it's okay in your lungs when it's vaporized.
Exactly. And then there's the nicotine, which varies wildly. Some e-liquids have none, but others go incredibly high. The research says up to 87.2 milligrams per milliliter.
Wow, that's huge.
Yeah. JUL pods, for instance, are highlighted for their high concentration, around 61.6 milligml. The research connects these higher levels to both their popularity and how quickly nicotine gets into the bloodstream, sometimes reaching levels similar to smoking a traditional cigarette, depending on the device. And using nicotine salts allows for these super high concentrations with less of that harsh throat irritation you'd normally get.
Oh, I see.
Making it easier to inhale large amounts, you know?
Wow, less irritation means you can inhale more high-dose nicotine? That certainly explains the addiction potential the research talks about. And all those tempting flavors, strawberry, coffee, even dessert flavors.
The research definitely flags the flavorings. Studies have identified specific chemicals like diacetyl, acetone, menthol, and others.
Okay.
And when tested in lab settings using cells, these flavorings alone can cause cell damage and trigger inflammation sometimes, the research notes, comparable to extracts from regular cigarette smoke.
Really? Comparable to cigarette smoke?
In some cell studies, yeah. So they aren't just innocent additions.
That's surprising. You'd think food flavors would be harmless. But it's about inhaling them once heated.
Exactly. The heating changes things.
What else is created when the e-liquid is heated up and turned into that aerosol cloud?
The heating process itself generates other concerning compounds, according to the research. You get things called volatile carbonyls, think formaldehyde and acetaldehyde, some of which are known irritants or carcinogens. There are also reactive oxygen species, which can damage cells, and even metals like nickel, lead, and chromium.
Metals? Where do they come from?
Often leaching from the heating coils or other device components.
Metals in the vapor. That sounds distinctly not good for your lungs.
Definitely a point of concern highlighted in the research. And then, of course, there's vitamin E acetate, or VEA.
Ah, yes, VE.
The research points to VEA, particularly in THC vaping products, as being heavily linked to the severe lung injury outbreak known as EVALI a few years back.
Right.
It turned up in many patient samples and the products they used.
And that raises another complication the research mentions. These devices aren't just used for nicotine.
Right. The studies note that e-cigarettes are also used to vaporize THC oil and other substances, which obviously complicates the picture when trying to assess the health effects of vaping as a whole.
Okay, so we know what's in them and what the devices are. Now for the big one, What does the science say about the actual health effects on your body?
Right.
Let's start where the vapor goes first, the lungs.
The lungs are certainly at the forefront. The most prominent acute issue the research details is EVALI e-cigarette, or vaping use-associated lung injury.
We all heard about that outbreak. What exactly did the studies find about it?
Well, the research described a range of symptoms, not just cough and shortness of breath, but also nausea, vomiting, stomach pain, fever, and fatigue.
Quite systemic then.
Yes. Diagnosing it involved specific criteria. A history of vaping recently, say within 90 days, cloudy patches on lung scans, ruling out infections or other illnesses, and often showing a particular pattern under the microscope, things like lipid-laden macrophages or a chemical-induced pneumonitis.
Okay.
The strong link to VEA, especially in THC products, was a major finding from that time.
So EVALI was a severe acute reaction. Are there other, maybe less severe immediate lung issues linked to vaping?
Yes. The research also mentions links to other acute problems in some cases, like certain types of pneumonia, eosinophilic and hypersensitivity pneumonitis.
Beyond immediate problems, what happens at a cellular level? What do the lab studies on cells and animals show about how vaping impacts lung tissue over time?
These studies provide concerning clues about potential long-term effects. The research indicates that exposure to e-cigarette vapor can cause what's called redox stress, essentially, an imbalance that damages cells.
Redox stress, okay.
It can also harm mitochondria, which are like the power plants of your cells, and even cause DNA damage, including breaks in the DNA strands themselves, single and double strand breaks.
DNA damage, that's concerning.
Very. These studies also show increased cell death, problems with immune cells like the ones that clean up your lungs, the macrophages and neutrophils.
Right.
Reduced ability to clear mucus, increased inflammation, and damage to the delicate lining of your airways and blood vessels in the lungs, the epithelial and endothelial barriers.
So it's not just irritation, it's fundamental damage happening at the cellular level, potentially setting the stage for future problems.
That seems to be the concern raised by these studies, yes.
What about human studies, even short-term ones? Do they show anything?
Some human studies cited show immediate airway narrowing right after vaping, although results aren't consistent across all studies. Some do, some don't.
Okay.
Interestingly, one study found that even after just an hour without vaping, healthy daily users had measurable reductions in certain standard lung function tests compared to non-users, like FEV1 and the FEV1-FVC ratio.
After just an hour of abstinence.
Yeah. This could hint at a tendency for airways to constrict acutely, maybe bronchospasm, though more research is needed to see if these changes are long-lasting or just temporary.
And that brings us to the big unknown. Does this lead to chronic lung diseases like COPD or lung cancer down the road?
This is where the research is still very much in progress. As the papers note, it takes decades of exposure to see population-level effects like those caused by smoking. We just don't have that long-term data for vaping yet.
Makes sense.
However, the animal studies are concerning. Some show persistent DNA damage after long-term exposure.
That's the kind you mentioned earlier.
Yes, and some animal models even developed changes that looked like COPD or resulted in lung adenocarcinomas, a type of lung cancer.
Wow, actual cancer in animal models.
In some long-term exposure models, yes. Now, these are animal models, not humans, but it's a red flag.
Definitely. Any human data pointing towards chronic issues.
Well, one human longitudinal study following people over time did find that former or current e-cigarette users had a higher chance of developing respiratory diseases like COPD, chronic bronchitis, or asthma over about 2 years.
How much higher?
The adjusted odds ratio was around 1.3, so about a 30% increased risk compared to never users in that particular study cohort.
A 30% increased risk in just 2 years from some studies is significant. Okay, so the lungs have immediate issues and concerning signs for the future. What about the heart and blood vessels? Cardiovascular health.
The research indicates that acutely, so right after inhaling, e-cigarette aerosol can cause an immediate increase in blood pressure and heart rate, particularly in people who don't smoke.
Okay, immediate effects and long-term.
Nicotine is a known culprit here, regardless of how it's delivered. The research highlights that nicotine can contribute to problems with the inner lining of blood vessels, endothelial dysfunction.
Right.
Make arteries stiffer, and negatively affect blood flow in the tiny vessels, the microcirculation. Animal studies also linked e-cigarette exposure to an increased tendency for blood clots to form thrombogenesis and enhanced platelet function. Both of those are risk factors for heart attacks and strokes.
More potential issues. Are there impacts on other parts of the body? What about, say, oral health, your mouth?
The research definitely discusses oral health impacts. Components in e-cigarette vapor are described as having properties that can damage cells, potentially cause genetic changes, genotoxic, and even potentially be carcinogenic.
In the mouth.
Yes. Specific problems mentioned include an increased risk of tooth decay, partly due to the sticky nature of the VG liquid and the sugar-like flavorings.
The viscosity and sweetness.
Exactly. Teeth discoloration happens too, though perhaps less than with traditional cigarettes. The research also points to effects on gum health and even dental implants. One study noted higher plaque and probing depth in e-cigarette users compared to non-smokers.
Okay.
And a precancerous lesion called nicotine stomatitis is mentioned as a potential risk, possibly related to the high temperatures involved.
So it's not just a harmless flavored mist for your mouth either. What about reproductive health?
Human data on reproductive health is quite limited, according to the research. Most findings come from animal studies.
And what do those show?
In those animal models, e-cigarette exposure showed adverse effects on hormone function, endocrine function, semen quality, like sperm counts and shape,
Oh, wow.
and embryo development, potentially impacting fertility or success with procedures like IVF. Plus, some metals like copper and certain volatile organic compounds found in the vapor are also known reproductive toxicants.
It seems like potential risks are showing up across many body systems in this research. What about the brain, particularly concerning addiction?
This is a major focus in the research, a really big deal. E-cigarettes are discussed as a potential gateway to nicotine addiction.
Especially for young people.
Especially worrisome for adolescents who might otherwise never have started using nicotine. The very high nicotine levels delivered by many devices, particularly with those nicotine salts we mentioned,
Right.
are identified as significantly contributing to their addictive potential, making it easier to get hooked, basically.
And we've heard reports of seizures linked to vaping. Is that covered?
Yes, the research mentions seizures in relation to acute nicotine intoxication, basically, nicotine poisoning.
Okay.
There's also a suggestion that PGVG might play a role through impacts on circadian rhythms, but nicotine toxicity appears to be the primary concern highlighted in the literature regarding seizures.
Any other risks that came up in the research? Physical dangers.
Sadly, yes. There's the risk of accidental poisoning, including tragic cases involving children, linked to the high nicotine concentration in some e-liquids. They can be very toxic if swallowed. And device malfunctions leading to explosions have caused burns and traumatic injuries, which is also documented in the research as a physical safety risk. Batteries exploding, things like that.
This is, well, it's a lot of information.
Yeah.
Painting a picture that's much more complex and concerning than some might initially believe. Which brings us to the central question often raised. Can e-cigarettes truly replace traditional cigarettes, and are they definitively less harmful?
The research tackles this directly, and the answer isn't a simple yes. On the cessation front, helping smokers quit, one randomized trial mentioned found that e-cigarette users had higher rates of staying abstinent from smoking after a year.
Okay.
0.18% compared to those using traditional nicotine replacement therapy, NRT, where it was 9.9% in that study.
Okay, so they can help some people quit smoking, according to that study. Double the rate, almost.
That study suggested so, but the research is careful to note that the abstinence rate in the NRT group in that specific trial was lower than typically seen with NRT.
Okay, a caveat.
Right. So while the difference was there, it needs to be interpreted with caution. Another study saw that smokers who switched didn't necessarily see big improvements in standard lung function tests. Although one measure related to small airway function, FEV 25%, 75%, did show some improvement in that particular group.
So maybe some small airway improvement for some, but not a clear picture of lung health bouncing back just by switching.
It's not a slam dunk, based on that evidence.
Now, what about the claim that they are less harmful than traditional cigarettes? That's the big selling point often, isn't it?
It is, and the research states that e-cigarette aerosols generally do contain fewer toxic chemicals than combustible cigarette smoke. That's a factual point noted in the papers.
Okay, fewer toxins overall.
Beauty, and its big but. They immediately emphasize that the long-term health effects are uncertain.
Right.
The incredible variety and customizability of vaping products, different devices, thousands of liquids, different ways people use them makes it extremely difficult to make a blanket statement about their overall safety.
So it's less about being safe and more about having a different mix of chemicals, some of which are known to be dangerous when heated and inhaled.
Exactly.
And we just don't know the long-term impact of that specific mix, especially with all the variations.
Precisely. And the critical conclusion highlighted across these research papers is that current scientific knowledge is insufficient to definitively say that e-cigarettes are less harmful overall than combustible products.
Insufficient evidence.
Especially when we talk about long-term use spanning years or decades.
That's a profound takeaway. Cutting through a lot of the public debate, it sounds like the less harmful claim, well, perhaps true for some individual chemicals compared to smoke, doesn't account for the overall long-term health picture, which we just don't have yet.
You've got it. And the research really highlights the complex public health balancing act. Any potential benefit for current smokers who completely switch and stop using cigarettes.
Right.
That has to be weighed against the very real risk of e-cigarettes leading never smokers, particularly young people, to start using nicotine and become addicted. The papers identify that risk youth uptake as a significant public health concern.
Because if one smoker quits cigarettes by switching, that's a potential individual benefit. But if 10 young people who never would have smoked start vaping and get addicted,
it's a net negative for public health.
that's the jumbo.
That's the challenge. And complicating the research even further is the fact that many users are dual users or poly users, using both e-cigarettes and traditional cigarettes or other tobacco nicotine products.
Right, using multiple things.
Which makes it incredibly difficult to study the effects of exclusive e-cigarette use and assess the true population-level impact or harm reduction potential.
So given this complex and evolving picture, what are researchers and public health officials focusing on next, according to these studies? Where do we go from here?
Well, the research mentions ongoing prevention efforts, things like FDA actions in the U.S., age restrictions, exploring flavor policies for certain products, trying to limit youth access, and various interventions aimed at young people.
But the research also points out how much we still don't know, right? What are the big research gaps identified?
Absolutely. The biggest is the lack of long-term human data. We desperately need more rigorous studies, like randomized controlled trials following people for many years, decades even.
Okay.
The sheer diversity of products makes standardizing research incredibly difficult. How do you compare studies when the devices and liquids are so different?
Sure.
There's also a need to study the informal or illicit market, which is unregulated. We need a much better understanding of the exact biological mechanisms, how these chemicals cause harm, and the specific toxicity of individual components when inhaled and heated.
So lots more science needed.
Yeah.
And all of this evolving science has to somehow inform public policy, right?
Exactly. The papers note the immense challenge regulators face. How do you balance the potential uncertain harm reduction benefit for existing smokers with the significant demonstrated risk of initiating a new generation into nicotine addiction?
Especially when the products and user behaviors are constantly changing.
Precisely. It's a moving target.
So let's try to pull this all together from what the research in these papers tells us. While the science is still building, what's clear is that electronic cigarettes are far from harmless.
Definitely not harmless.
They contain substances that can be toxic when heated and inhaled. They're linked to severe acute issues like EVALI and concerning findings in lab studies regarding potential long-term damage to cells, DNA, and multiple body systems.
Lungs, heart, mouth.
Including the lungs, heart, and mouth. And the risk of nicotine addiction, particularly for young people, is a very real and significant concern highlighted throughout this research.
Absolutely. And when it comes to the big question of whether they are a safe or definitively less harmful replacement for traditional cigarettes, these studies make it clear that our current knowledge is insufficient to make that claim definitively, especially concerning long-term use. While they might offer a pathway out for some smokers, the risks of initiating nicotine use in non-smokers, particularly youth, and the many unknowns about long-term consequences mean caution and careful consideration are absolutely necessary, just as the research suggests.
It's a really complex puzzle, but hopefully this deep dive into what the actual research says helps you see beyond the simple headlines and understand the nuances.
It's about looking at the evidence and recognizing what we know, and perhaps more importantly, what we still need to learn.
Absolutely. Here's something to chew on after this deep dive drawn directly from the challenges laid out in this research. Consider the immense challenge faced by public health bodies and regulators worldwide. They are trying to navigate a path that balances the potential to help current smokers quit with the significant and proven risk of hooking a whole new generation onto nicotine through these diverse, rapidly evolving and appealing products. What do you think is the most critical piece of information needed or the most important action to take to solve that complex public health puzzle?
A fascinating and a vital question for the future. Really makes you think.
We hope this deep dive gave you some valuable insights.
Yeah.
If you want to keep exploring complex topics like this, breaking down the research, remember to subscribe to the channel.
Please do.
And if you know anyone who's curious about what the science actually says about vaping, please share this deep dive with them.
Thanks for joining us.
See you on the next deep dive.